Hello YouTubers, this is Mdom, and in this video, I'll be showing you how to reverse engineer the program that I had on a Steamgifts Puzzle. So the goal that I want is to have this program here, app, to actually print hello world. So to start on reverse engineering, you want to do an object dump on this program, which is object dump with a -d parameter, the program, and we want to output it to a file. Let's say disassembly. Oh god, I can spell disassembly text. So we could actually see disassembled code while we are reverse engineering it. So we'll start with the main here, and then let's try running the app, and we can see that it wants 4 files. So we're gonna create null files for now. So echo in1, and we're gonna just do that to the same in1, in2, in4. Oh wait, actually in1, there's actually not null files because this one has a new file in it. So let's actually do another one. So command echo, I think it's -e or -e or -n. No, it's a -n. So if we actually do, because right now this has a 1 byte for each of this file, so let's do echo -n in1, and if we lsla, now it has 0 byte, so that's a null file, proper null file, and those are 4 files. And now we're gonna try to use GDB as our debugger. So GDB app, then we're gonna put a breakpoint on main. Then let's try running this in1 into our null files, and then if we continue, it says empty files not permitted, so with an exit code 1. So empty files for what? Is it for all the files or just the first one? So we're gonna do the empty now, empty, just do in1. Let's see if this tells complain. GDB bmain. What did I do? Oh, I just typed GDB with GDB app bmain r in1 into in3 in4. Does it say an error? So you actually need to have at least 1 byte for each of these files, so we can't have null files for this. So we're just gonna do it again, echo nothing, but this time with a trailing new line into in3 in4. But with this, actually, if we run the program, we actually already have the first guard broken if we have a new line with echo nothing to something. So if we bmain breakpoint main again, or just run it, no breakpoints, we'll have the error exit code 5, and exit code 5 is in the assembly code is something around here. So we're actually a bit far already. So to just explain the first guard code, so just quickly explain it. So for this one, if we see here, it's called get data file. It's basically reading the four input files, and then in this compare, which is basically calling a to I first before comparing. So this part of the code, this is comparing the first character on the first file to a and passing it to the a to I function. And then what it's basically saying, what AX gets the return of this function, it puts to a pointer address, which is this, and then we're comparing 0 to that address. So a to I is a string to int converter, and it only returns 0 if it gets an error, and it gets an error if you feed it a non-number string. So let's say ABC, or for in this case, we feed it with a new line, so it's actually gonna return a 0. We compare it, that's true, then jump equal and to 8080V, and we actually bypass this guard, which is error code 3. So now we're now comparing the second file here on the second guard. And if we look at the code, you can see here there's a compare word, so comparing 2 bytes to EF to A. But if you remember, we're using x86 with a little engine, so this is actually in reverse order. So to beat the second guard code, we're gonna use echo, but I'm gonna use bash first because my echo doesn't work in non-bash code. So echo -n, that's without a new line at the end, -e, that makes us allow input hex code to the file, since this hex code, which is EF2A, is non-printable code. So we're gonna do X, and remember it's reverse, so we're gonna do 2A first, and then EF, and then just output it to into, and we're gonna exit from bash. And if we check into, we have 2 bytes, which is some garbled message because it's non-printable. And if we go to GDB again, and if we run in1 into in3 in4, oh wait, my bad, I didn't do GDB app, or in1 into in3 in4, we got now an error code 6, and error code 6 is here at the third file here. So we now need to defeat this third guard code. So this third guard code is actually a string copy for the third file, and it string copies the contents of the third file, and it tries to compare it with this hex file, which is 3333 on this specific address, 4404 specific address, and 545 in a specific address. So we're gonna go again, and this time use bash again, since we're gonna use an echo and E on the same parameters. And this time we're gonna input it with this string, which I already have pre-copied. Copy and paste. Copy, paste. Yes. So we're gonna have this, and we're gonna output it to in3. And just for information, this is just a quick code to make this print out. And the use for this is we're gonna examine the memory, and then I'm using this incrementing numbers so we can pinpoint the address that we need to edit. So we're gonna exit bash again, exit, then GDB app. Then this time we're gonna put a breakpoint. We're gonna put a breakpoint here just before the first compare. So 0 0 804 8871. Oops, I forgot the star, since it's basically an address. And then we run in1, in2, in3, in4, which our in3 is this long incrementing hex code. And now we're there. Breakpoint 1 at disassemble. I forgot. It's okay, we're here. We're at the first compare. So we're gonna check the address on ESP. So XX, that's 32X at ESP plus, and since this is hex, we want the plus to be converted to an integer. So that's gonna be a 44, and we convert it to decimal, plus 68. So ESP plus 68. And as we can see here, we need to go replace 54, 55, 56, 57 with 33333. So we're gonna quit again. Exit. What? Oh, yes. And then we're gonna go in bash again. with this echo, and we're gonna replace from 54 to 57 with 333333. I didn't show you that it's actually an error, but I'll show you in the 4444. So exit bash again, GDB app with the same breakpoint, which is here. Breakpoint, an address 008 084 8871, then R in1, in2, in3, in4. And if we what do you call it, poke at the ESP plus 44 address, we're gonna see that's actually edited now. So ESP, and we use plus 68. Now we see it's 3333. So if we display IPC and we next instruction for this, so compare 33 to 44, and now if it's not equal, if you can see here, it says not equal. This is actually going to the exit code, which is sorry, error code, which is this, the 6. So we need to bypass this jump code, which we will, because it's not equal. It's actually equal, NI, and now we're at the second compare 4404. And this time I'm gonna show you that's actually exit to 6 with the error code 6. But before that, we're gonna compare address again, but this time it's ESP plus 3C, but since we need to plus to the decimal, it's actually a plus 60. And as you can see, we need to replace 46 to 49. And just to show you that it's actually an error, we're just gonna continue, and we have an error code 6. So we exit from GDB again with bash echo. Now we have the 3333 replace here, and we need to replace 46 to 49. So this is 44 4 4 4 and 3. Exit. We go to bash GDB again. GDB app. We now let's put the breakpoint now here at the 5th, since we're sure that we're gonna bypass this jump not equal here. So B address again 804 8885 R in1, in2, in3, in4. Display IPC, so we can see where it's in the assembly code right now. So it's comparing 555 to 38. So if we actually examine the memory on ESP plus 38, which is a hex code, so we need to convert plus 56. We need to replace 42 to 45. And just to show you, actually I don't need to show you because we already bypassed the jump not equal check here, but we're still gonna get an error code 6 because we still need to replace this. And now quit again, bash, and this time we're gonna replace 42 to 45 with 55555 55 55 55 55. And now we should be able to defeat the third guard code with this. Quit GDB exit command, GDB app, and if we do R in1, in2, in3, in4, we can see that we got a segmentation fault and actually not an error. Weird. Why do we have a segmentation fault? So if we look at the code here, so we jumped at 804.896, which is this, and it's now going and it's calling this underscore function. And if we look at above, it is the underscore function, which is this. So what it's doing here, so it's doing a string length and doing a string copy. So possibly it's trying to get the string length of the fourth file and copy it to something. Then it moves 1 to the return and then returns. If we notice here, it calls this, and remember we have a 1 return on the function, which is copied at AX, and this thing is actually doing what it's doing. It's asking does AX equal to 0? If it's equals, which is this, we go to the hello world prints with this. But unfortunately, since AX is 1, we're not gonna go with this jump. We get an error code 7 and we exit here. So what do we usually do here? So this is, you need to do a buffer overflow attack for the last one. And to do it, we're gonna do it again, just in the last time. But in this case, we're gonna feed this long string in N4, and we're going to observe the program on where it crashes. So we quit, yes, we bash again, and we're gonna get the normal, which is the unedited part, and we're gonna output it to N4. And now we're gonna exit or quit, and we're going to ask GDB where the program crashes. So R, N1, N2, N3, N4. And as we can see here, it doesn't actually tell where it's segmentate, where it's crashes. Alright, I'm back. Okay, I think I got the problem now. So if we go to bash again and just go on the final N3 print, which is this, I actually smashed until up to the 4th file. So we're gonna reduce this string up to the 3333 and just there. We're gonna stop there. And then we're gonna use GDB again and running it again, and let's see where it crashes. And as we can see here, it's segmentation fault at 34, 35, 36, 37. So what does this mean? So it basically tells us that when we go inside this underscore function, it goes the string copy command. What it does is, since the string is really long, it smashes all the memory addresses on the stack, which is the return address back to main, and we're getting a 34, 35, 36, 37, and then we can exploit that. Since it's trying to return to this address, we can overwrite the string that we have in for, and we're gonna replace this with the address in main that we want to skip, or I mean to return. So basically, we want to return not on the test, not on equals, not on the move, not on a jump, but instead here. We want to return at this address, right? So we're gonna write this address to this address in the string. So we're gonna exit again, quit, we bash, and we go to N4, and then we replace 34, 35, 36, 37 with this address. Alright, so here we're gonna replace 34, 35, 36, 37 with the return address on main. And remember, since x86 little engine, we're gonna write it in reverse for each byte. So we're gonna write 80, and then for here, this is 88, this is 04, and finally this is 08. Since object top doesn't include the first 0 here, since it's 4 bytes. So 80, 88, 04, 08, and then that should be it. So if we do app with in1, in2, in3, in4. Now prints hello world properly. And that's it. Thanks guys for watching.